Hello, ladies, gentlemen, other. Looks like Tycon has sent me something really cool to play with. They've sent me their TPDIN-Monitor-WEB3. Can you read that? There's even a little QR code here. Look at how filthy my hands are. That's permanently stained, by the way. Alright, let's check this thing out. Ooh, manuals. I like manuals, because I'm a psycho. Alright, so let's put these over here next to the eyeball. Alright, so what do you get in the box? Everybody likes to know about boxes. Let's take a look at this. So this is the TPDIN or WEB3. This comes with... let me just put my phone on airplane mode. And there we go. Alright, so this comes with a thermal probe. Yay. Yes, where's that that paramedic that says don't put these things in certain places? Anyway, this thing also comes with this, the actual module itself. Now, what is this, you may ask? Well, if you work in telecommunications or off-grid systems or solar or backup power or anything like that, you're going to be familiar with these. They're used in industrial settings as well. What these guys are is this allows you to monitor certain metrics. Okay, in this case here, you've got 4 voltage monitors and 3 current monitors in it. Oh, sorry, 4 current monitors, I believe. Yep, 3 plus a shunt. I wish this actually supported just 4 shunts, period. It'd be far more useful if it supported either 4 shunts or 4 current transformers. That'd be pretty handy. But it's also got some relays on it. You've got 4 relays on here. So channel 1, let's see here. Common, normally closed. Channel 2, common, normally closed. Channel 3, common, normally open or normally closed. Okay, cool. I'm assuming that we can change that setting. So it looks like 3 and 4 allow you to actually change the position, the resting position of the relay, which is kind of cool because you can use that in a situation like that where it's actually normally open, and you've got it set to be normally closed when power is applied to the unit. When power is cut to the unit, this is a little hack by the way, then of course the whole system collapses, which means that the relay itself will go open. So kind of a neat little hack you can use to keep an eye on this thing as a secondary measure. Reset button, 2 amp fuse for the unit itself, plus you can tie in an MPPT charge controller from Tycon, and I'll bet you dollars to donuts, you could probably hack something together to make this work with other MPPT charge controllers as well, if you need something bigger than Tycon has to offer. Let's see what else we got here. That is a separate voltage input, but it supports PoE, RS-232, and RS-485. And, of course, as per my typical video, we should take it apart. Let's see what's inside of this thing, because realistically, I can't see there being anything really secretive about this. It's a fairly common type device. There's only a couple of companies that make these, actually, that I know of. Tycon, Planet, and ALGcom make these. Now, Tycon's been on the scene for a very, very, very long time. They make some really wicked gear, actually. In fact, I've used quite a bit of their gear. You've probably seen many videos I've done about their switches as well, because they make great little switches. Let's see here. There we go. I've almost got all the screws out. You know what's really going to suck about taking all the screws out of this thing is putting them back into this thing at the end of the video. There's been a couple of videos that I've done for you guys where I've taken all the screws out of something, and then after the video's gone, and put them all back in. Let's see here. Almost got the screws out. Alright, let's take it apart. So first of all, take the faceplate off. Ooh, got all sorts of goodies in here. What do we have inside the box? Neat. Okay, so what do we have here? We've got daughter boards. What do we have for daughter boards here? This is kind of interesting. V in, V out. Oh, wait a second. These are surge protectors right here. Those are surge protectors. What is this board, though? I don't know. There's our 4 relays. Nice. A thermistor. There is a thermistor built in inside. It looks... Oh, wait. R89. It looks like a thermistor. That's not a hydrometer, is it? Huh. It might be... there might be another thermal resistor inside for the MCU, maybe. Let's see here. And what do we got over here? We've got some more diodes for surge protection. We've got a GDT on the power input. And MOVs, GDT, MOVs, and fuse. This is a really robust power section to protect it from exploding. Looks like this is a inductor and cap. This actually looks like a boost board, maybe a boost buck board here for the power coming from the unit. Just a voltage regulator. There's quite a few fuses on here. There's tons of fuses on this board. There's a spot for a variable resistor there too. And what do we got? So we've got the RAM chip, and then, I'm not on camera, am I good? A PIC processor. That's the SOC. Here's our, let's see here. This would be for tying into this bad boy to be able to program it, write it. Nice. Oh, and look. You can actually change. Is that so? This is interesting. Oh, I see what you can do. Okay, so for relay number 3 and 4, here's a jumper that sets it for normally open and common. Normally open common. Oh, I see. So you could actually move that jumper if you really wanted to change its state, its default state. That's kind of cool. Yeah, not much to look at anyway. What's on the back? Looks like some VREGs. This would be for all the voltage sensing, I'm assuming, and current sensing and all that. Let's see, where is the current? If this is capable of monitoring current, there's going to be some shunting resistors on here somewhere. Huh. Let's see. What do we got here? There they are, look. Current shunting resistors. Okay, so anyway, let's take a look at some of the specs on here, by the way. So this thing can actually monitor 4 voltages up to 80 volts. It can also monitor, what is it? Let's pull out the tech sheet. I like reading. All right, let's see here. Corner. It can take up to, okay, so this is for remote power stations, backup power systems, solar systems, wind-powered systems, industrial sense and control, process automation. Yay, because you can also do some basic programming in it, right? Don't exceed 80 volts on the voltage inputs, or 20 amps on the current inputs, or 10 amps on the relays, or the unit could be damaged. This kind of damage isn't covered under warranty. No doubt. Moisture. The Web3 is designed to be used indoors or outdoors in a weatherproof enclosure. Avoid getting the Web3 wet. This kind of damage isn't covered under warranty. Telnet. The unit can be accessed via Telnet to see the present readings and also control the relays. You can toggle relays using the number keys on the computer 1 through 4. You can also reboot the unit by typing R. Default Telnet username admin and password is Tycon. Battery status. If measuring voltage of battery systems, typical state of charge readings are as follows. These readings are without any load on battery. For max battery life, don't discharge under 50%. Nice. So, handy little sheet, actually. It's kind of nice that they included that. But yeah, there's lots of examples of how to set it up, and here's your pinout for your RS, or your serial port. All right, so now let's plug it in and log into it and see what we got here, okay? If you guys want to see me do a lab with it, just let me know in the comments. I'm just going to use my ProZeet power pack here to power this thing up, because as I mentioned, you can power it via PoE, 24 or 48 volts, which means it's diverse. It's verse. You could use this on a Ubiquiti power supply. You could use this on a telecom standard power supply. It's a versatile little unit, and all the pieces are everywhere. Spooky. Okay, let's go over to the computer now for a second. All right, switch screens. Hi, welcome to the computer screen. Let's take a look at what this thing does now by logging into it. So at first glance, you can see the awesomeness of the dashboard. And here's our relay states. Cool. We can cycle them. Not cool. And let's cycle this one. Okay, 15-second cycle. There's going to be a parameter in there where you can change that, I'm sure. If I click on the switch... Oh, you know what? That's a satisfying click. I'm going to put my lapel over here on top of the unit for a second. Listen to this satisfying click. Isn't that lovely? Oh, I love that click. Oh. Booyah. Alright, let's put my lapel back on my hat. Best way to do the lapel mic, apparently. Especially when I'm not showing my hideous face. Alright, so there's the primary screen. Not connected to the internet. External temperature, internal temperature. It's in freedom units. See, with an F for freedom units instead of, Celsius. Alright, so let's move over here. Log. There's lots of handy stuff in this. This is a really pretty log. Look at all this goody stuff. Oh, wow. And it does graphing. Oh, this is sweet, dude. And dudette. And, oods. Look at that. This is really, really cool. Wow. So there's all of our logging, everything that's happened on here. I love that you can graph this stuff, right? Okay, network. Here's our network settings. Excuse me. MAC address. You can change the host name on it. Okay. You've got, let's see here, your usual stuff, username, password. Alright, guest permissions, that's kind of handy. Let's go to system here. Okay, it's pretty standard stuff under system, your times. You can sync it to the PC. I like it when people do things like that. That's really intelligent. Let's change this over to what the rest of the world uses. Just because, we use Celsius metric. Okay, so sensor offset. So this is where you can counter issues with the sensors. So like, for example, if you've got a current sensor that's reading like, say, 500 milliamps when there's nothing there, you can compensate. So that's all done right here. And I believe that there's a spot where you can actually set the voltage as well. That might be how that works, but I'm not entirely sure. I think that Tycon was telling me that for the current shunt, you can set it as a 50, 75 millivolt or 100 millivolt right there for the shunt. I will have more questions for them. And if you guys have any questions, please enter them in the comments below so that, Tycon can peruse the video and answer the questions for you. And if you guys want another video of me doing like a lab or something a little bit more in-depth, by all means. Oh, sorry, there's the shunt resistor settings. Look. Nice. Okay, so the max current on the shunt is only 30 amps. So I'm going to say a little bit of critique here. With this unit having 3 voltage inputs on it, let me grab the reference. 4 voltage inputs and 3 current inputs and a shunt, it looks like. It's kind of limited as to what you can do. Because in a lot of solar plants, we go way over 30 amps. So it says 50 amps right there. See, I'm a little confused. I'm going to have to actually read that. I'm certain that it can go higher than that. But anyway, so with the voltages being maxed out at 80 volts, many charge controllers will go up to 150 volts. Also, if somebody wanted to use this in an AC scenario where they can actually run the 3 voltage inputs to AC power sources instead to monitor 3 AC sources, they aren't able to do that because the 80 volt maximum. With many solar arrays, especially larger ones, to be able to get better efficiency and longer cable runs, we run them at 100, 120, and 150 volts, which means that the voltage input of 80 volts is very limited by half. So being able to, like, a change that I would definitely love to see on this product is that we can monitor AC and DC up to, say, 120 volts, or maybe even better, if there was any way to monitor up to 150 volts, that would ensure that we can monitor most solar equipment. And with the AC ability, for most people in North America, we'll then be able to actually monitor AC. Now, if you want to make this thing national, if you can actually set the voltage monitoring somehow, or even have a different version that can monitor up to 240 volts, that'd be amazing. The current limitations are also a little bit annoying. With the current, instead of using onboard current shunts, it would be far more versatile, if we could instead use four of our own choosing current transformers, whether they're shunts or current transformers, taps. Because then, if you're putting it in an AC situation, you can simply use a current transformer, or if you're using it in a DC scenario specifically, you can just use a shunt. So, and that would also alleviate the problems with current limitations of the actual circuitry. You'd be able to actually, your current limitations would only be limited by the external device that you're using on here. All right, so moving on. Here's some relay control stuff. Isn't that pretty cool? So look, you can control things based on parameters of time, temperature, voltage, current, ping. So this allows you to do like ping resets and stuff. You can actually monitor current, and if the current goes too high or too low, you can control a relay, which is awesome because this is great for a wind turbine. If we see that the voltages are full, you can actually use this to activate a brake for a wind turbine. So I think there's so many different things you can do with this on an off-grid plant. Having this kind of programming ability, this is just awesome. Awesome sauce. I mean, like, look at that. External temperature, internal temperature, battery temperature. This is wicked. I mean, this is some really versatile programming, and I like that the abilities that they've added for us. And that's per relay, too. So, now alerts. So, you look at all these parameters. So, you can either... It looks like you can use this with standalone. I haven't seen anything SNMP yet. So I'm just going to assume at this point, let me just check. It should be SNMP. I would assume this is SNMP capable. Let's just double check that. Oh no, it doesn't look like this is SNMP at all. Oh wait, no, I'm dumb. I'm getting them mixed up. Sorry, SNMP. Yes, there we go. SNMP or email. Perfect. Okay. Perfect. It's right there. I love to see. That's how the ADHD brain works. It's like I'm looking for something. I could be staring at my favorite coffee cup. Where the hell is it? It's not there. Well, it's right in front of me. That's a defect of my brain. Anyway, going back over here, I had a minor panic attack there. I'm like, oh no. Sorry about that. Looking here. Here's all of your alerts, so you can set specific parameters to send notifications, and it's got the ability to send email. No, SSL, typically port 465 is not supported. Unencrypted, typically port 25, and TLS, typically port 587 are supported. That's something that should be fixed. This should be brought up to date because I know I personally use Gmail for a lot of server monitoring and notifications, and Gmail's getting kind of uptight about, insecure mail. So it makes it a little bit more difficult. But I mean, TLS is probably okay. Okay, yep. So anyway, this thing can notify you directly. Kind of handy, no? Or you can use SNMP. Thank God it supports SNMP. I was certain it did. I was going to say that was pretty weird if it didn't support SNMP, because these things are designed for a plant scenario, which means that, yeah, by definition, they should have SNMP to integrate with something like Libre or, pick your NMS, right? Let's see here. MPPT. Wait a second. Okay, good. It supports 1, 2, and 3. Nice. Okay, now back over here. This is for the Tycon MPPT charge controller. So all of this will tie together. So you can actually use the serial interface on the front of it to actually tie it into one of Tycon's MPPT charge controllers. And then this will actually allow you to interface with it and pull metrics. And it looks like we can also control it. PV voltage is greater than delay. Oh, interesting. Very interesting. I'm liking this. This is actually kind of cool. So there's a lot that this guy can do. Oh, and of course the obligatory software update page. So that's it, basically. And if you guys want to check this thing out on the actual manufacturer website, I love that you can sync the time to your computer time. That is just wonderful. Oh, my goodness. Let's see here. Here we go. Let's go to the Tycon Systems website. We go to Tycon, go to Products. Tycon Solar is where you're going to find this thing specifically. Hey, you know what? While we're in here, let's just take a look at the MPPT charge controllers that they support. OLED display. Look at these guys. They have a 40 and a 60 now. Last time I looked, I don't think that they have. These are sexy. Oh, wow. 1224. Here we go. 6048. That's the one that I'd be going with right there. 60 amp, 48 volts. That will give you, let's get the calculator out. Let's do a quick little bit of math here. Okay, so if I get my calculator out, and I go 48 times 60, so that supports up to 2,800 watts of solar. Nice. Now, by the way, the reason why I mentioned that as well is notice that there's a 6024. This is why you want to run at 48, which is also telecom standard, coincidentally. Watch this. 24 times 60. Oh, at 24 volts, you get half the wattage capability of the solar array. And many of you guys might be saying, but my site's only using 100 watts. It's like, yeah, but check this out. Watch this. 100 watts times 24 hours, because it's going to consume 100 watts all day for 24 hours. That's 2,400 watts per day. Okay, so now let's divide that by 5 hours, because we want to assume we're going to try to charge the battery bank within 5 hours, right? Because that ensures that the batteries will charge, you know, on a good day, fast. So we need a minimum of 480 watts to charge a 100 100 watt site. Now, if we do some math here, I'm going to move backwards, okay? So 48 times 60, okay, at 2880. Okay, divided by 5. So if we were to have 500 watts running at a remote site, you would need the maximum capacity of that 48 volt, 60 amp charge controller. You would need a full, what was that again? 2,800 watts to be able to charge that in an appropriate amount of time, okay? And some of you guys might also say, well, why do you want to charge it in 5 hours? Well, it's like, well, look at it this way. My typical rule of thumb with a standard solar site is start off with 3 days autonomy and the ability to charge it within 5 hours. Now, this also varies depending on region, because if you're in a region where you can go for days without any kind of sunshine, then what you're going to want to do is you're going to want to account for that, okay? So maybe you need to have 5 days or 7 days of autonomy, but then you want to make sure that you can charge up your batteries within a day, because if you get one good day, it'll charge them. If you got a crappy, cloudy day, they'll charge just not nearly as fast, and it'll probably take multiple days if it doesn't draw it down, okay? Because remember, nighttime, there's no sun. We usually get anywhere from 5 to 10 hours of sunlight, depending on where you are, okay? So anyway, that is the TPDIN. And, oh yeah, you see, I ADHD'd again. Let's see here. Tycon Solar. I wanted to take you guys to the actual TPDIN-Web3. And here it is right here on their website. You can also buy it from your favorite wholesalers. Look at all the cool stuff they have. What? They got a new one? TPDIN-SC, a 4820 20 amp MPPT charge controller with 7-port gigabit. So wait a second. Tycon now have a switch. It's a dual voltage PoE switch, 35 watts per port, that also has a 20 amp MPPT charge controller built into it. You know, if that thing can run OSPF, that can do most of what you need. But, I wonder if they'll give me one of those to do a demo on. I'd probably have no use for it, but it'd be pretty darn cool to play with anyway. Let's go back over here. So here is their TPDIN-Web3 monitor. Monitor Web3? There you go, guys. Anyway, so there it is. There's some example setups or configs for it. Actually, one of my guys is actually running a wind/solar site as well, so this is actually kind of cool, because that's exactly what we're doing. Here's all the details, by the way. You can read that all on the website. And look, they now sell breakers and everything. Tycon is really looking out for WISPs and off-grid sites. This is really cool. All right, so I don't think I've got anything else to say. Don't forget, guys, like and subscribe. Leave your comments below so that we can answer any questions. And if you guys want to see me do a lab with this, please tell me in the comments. And if you guys want me to, then I will do the lab. And if you guys want to help feed me, because I live in Canada, in Ontario, one of the most expensive provinces and one of the most expensive countries in the world, join my Patreon and pitch in $1 or something. Anyway, thanks, guys. Have a great day. Catch you later.